So in this video, I'm going to explain about the instruction which is called XCHG, exchange H and L with D and E. So this is the last instruction of the data transfer instruction group. So first of all, we'll see their opcode. So opcode for this instruction is XCHG. Here it is XCHG, and operand it is not required here. So it should be written here as a none. So let's say we can understand their functionality in detail with the example. So let's say that instruction is XCHG and no operand is required because their operand is by default. So the functionality of this instruction is exchange HL register pair with the content of DE register pair. So the content of H will be exchanging with D here, and the content of L is going to exchange with E here. So let's see here, before execution of this instruction, if the HL instruction pair is having the content like this, so here this is H, this is L, this is 20H, this is 50H, and for this DE register pair, here for this DE register pair, if their content is 7FH and here if it is having D5H, so what will happen? That the content of HL register pair will be exchanging with the content of D register pair. So here this is called higher byte. So higher byte is going to exchange with this one. So this content of H will come to the place of D, and the content of D will come to the place of H. Similarly, for the content of L, it is going to replace the content of E, and the content of E is going to replace by L here. So we can say that it is interchanging the content of H to D and here L to E. So higher byte will be exchanged with the higher byte, and lower byte of the HL pair is going to exchange with the lower byte of D register pair. So here, after execution of this instruction, what will happen? The content of HL you will find out here. After the exchange of this, the content of HL will become this content of H will become now 7FH, and the content of L will become here as a D5H. And in this case, the content of D and E will become, the content of D will become 20H, and the content of E will become here as a 50H. So by this way, it will produce the result here. The content of HL register pair is going to exchange with the content of DE register pair. Higher byte of HL register pair is going to be replaced by the higher byte of this DE register pair, and similarly for the lower byte of HL register pair is going to be replaced by the lower byte of D register pair. So after execution of this instruction, this will be the content of HL register pair, this will be the content of this DE register pair. So here this HL and DE, both the register pair is available inside the processor memory organization. And how it is happening? This is happening with the use of the third register pair, which is called temporary register pair, as a W and Z. So in the memory organization, you might have seen, or like we can say that in the register organization of this 8085, you might have seen their W and Z are these two temporary register pair which is used for the execution of this instruction internally. So that WZ register pair is not available to the programmer or to the user. It is reserved for the processor to execute this kind of instruction. So either HL register pair or D register pair, first it will be copying into WZ, and then that DE register pair content is copying into HL by retaining HL content into WZ. So once the DE content is copying into HL, then from WZ the content of HL will be copying into DE register pair. So by the end of the operation, their HL register pair content, D register pair content interchange, and here we are not using any other operand, and here there is nothing more to specify. So by default the register pair HL and DE is used for this instruction. So that is the reason no operand is required to mention in this instruction. So now we'll talk about their size. So this instruction is represented or it is written only in terms of English alphabet. So their size will be 1 byte here. Now as a machine cycle, this is doing only opcode fetching. It is accessing the memory only once to get their opcode, because HL and DE both are residing inside the processor register itself. So internally it will be copying from HL to DE or DE to HL. So that is happening during the execution timing of this instruction. So that is the reason it is required only one machine cycle. So that one machine cycle is called here as a opcode fetch. It is not going to access the memory more than once. So that is the reason it is called here opcode fetch operation only. And as we know that by default for opcode fetch operation, the time required is only 4 T state. So as a number of T state we can mention here as a 4. So by this way this instruction is completed here. But one more important point I would like to specify here. So that is, in the note you can mention this point here. So what is that? In all the data transfer instruction, we can write it here, in all the data transfer instruction execution, no flags are going to be affected. So further I'll teach you about that, the number of flags and their functionality in this 8085. So here the intention to say this point as a note is that whatever we have the flags in 8085, by the execution of all these data transfer instruction, no flags are going to be changed. Whatever is their status before execution of this instruction, even after execution of these instructions, the status of flags are not going to change anything. So it will be retaining as it is. That is the reason I mentioned this point here in the note, that in all the data transfer instruction execution, no flags are going to be affected. So by this way, data transfer instruction group is completed. In the next video, first we'll explain about the flags used in 8085. After then we'll explain about the arithmetic instructions used in 8085 in detail.